In this question, we're told that Joanne is flying a kite and she has let out 228 meters of string. So that's why we've written 228 meters right here. We're also told that she can estimate the angle of elevation to be 45 degrees. So here's the angle of elevation right here, and she's estimating it to be 45 degrees. When we label our triangle, we end up getting opposite over to this side here, adjacent here, and hypotenuse. And we're asked to find out or figure out how high the kite is in the air. So because we're trying to figure out what opposite is and we're given the hypotenuse, we're going to use our sine ratio. Substituting in what we know, we get sine 45 equals x over 228. Punching everything into our calculator, we can determine that the kite is 161.2 meters high. In the next question, we're told that a tree casts a shadow that is 38.5 meters long. We're also told that the angle of elevation of the sun is 54 degrees. That's what we have here. When we label our diagram, opposite is over to the far side here, hypotenuse is always opposite the 90-degree angle, and adjacent is the side that contains the angle that we're focused on with the hypotenuse. Because we're trying to find out the opposite side and we're given the adjacent, we're going to use tangent. So tan of theta equals opposite over adjacent. Plugging in what we know, we get tan 54 equals x over 38.5. And when we solve this, we end up getting x equals 53.0 meters, which means the tree is 53 meters tall. Let's take a look at the next question. This question is asking how long the shadow will be when the sun is at an angle of elevation of 18 degrees. So I've redrawn my diagram. I've stated that the angle of elevation is 18 degrees. We know that the tree is 53 meters tall. That hasn't changed. And we're going to be solving for the length of the shadow. Because we know the opposite and we're looking for the adjacent, again, we're going to use tangent. When we plug everything in, we get tan of 18 equals 53 divided by x. Moving x to the top on the left-hand side, tan of 18 down to the bottom on the right-hand side, we can solve and get x equals 163.1 meters, which means the shadow, when the sun is at an angle of elevation of 18 degrees, will be 163.1 meters. Now let's take a look at the last question. In this question, we have two buildings. We have a taller building and we have a shorter building. And from the top of the tall building looking down, we're told that the angle of depression to the top of the shorter building is 27 degrees. We're also told that the angle of depression from the top of the taller building to the bottom of the smaller building is 64 degrees. In this question, we're asked to determine the height of the two buildings. As you can see, we have two right-angled triangles here, and we can use our trig ratios to solve unknown sides. In the blue triangle, the side that we're looking for is x, which is going to be the height of the building. Because we know that the angle of depression is 64 degrees to the bottom, we also know that the angle down here in the bottom corner is 64 degrees. And we also know the adjacent side is 14.7 meters, the distance between the two buildings. Because we're working with opposite and adjacent, we're going to solve for x using the tangent ratio. Substituting in what we know, we get tan of 64 equals x over 14.7. Moving 14.7 up to the left-hand side, we can solve for x and determine that the height of the taller building is going to be 30.1 meters. Now, we don't have a triangle that is going to tell us right away how tall the shorter building is, but we do have a triangle that will tell us the difference in height of the two buildings. So in this triangle, we know that the angle down here is 27 degrees, which is the angle of depression to the top of the smaller building from the top of the taller building. We're trying to determine the difference in height, which I've marked as y, and we still know that the two buildings are 14.7 meters apart. Labeling with opposite and adjacent and hypotenuse, y is the opposite side and adjacent is 14.7, which means we'll use tangent to solve this. We get the tangent of 27 equals y over 14.7. Moving 14.7 up to the left-hand side, we can solve for x. We can calculate y as being 7.5. So that means that the difference in height of the two buildings is 7.5 meters. So if we take the height of the tall building and subtract 7.5 meters, we'll be able to determine the height of the small building. So we know the tall building is 30.1 meters tall and the short building is 22.6 meters. Hope this video has helped. If you have any questions, let me know.